Hello everyone, good morning and Jai Swaminarayan. Today for standard 11th science in physics, we are going to cover chapter 3. The title is Motion in Straight Line. The topic that we are going to cover is first the definition of motion, how to describe the motion, position, path length and displacement. So starting from the definition of motion, as you all know that motion means change in an object with respect to time. Means an object changes its position from start to end and take a time interval. For example, when we run or when we are riding a bicycle or when we are walking, right now I am also walking, so you can say that I am in motion. Another example is the flow of blood in our arteries and veins. So the flow of blood is also a motion. And another example is the flow of air in from our lungs to out our lungs. So the flow of air is also a motion. Now to describe a motion, 2 points are required: velocity and acceleration, that we will see afterwards in this chapter. Right now we will limit ourselves to only the study of motion in a straight line, which is also called rectilinear motion. Now first of all, position. What is the position? Any object has a position, a point where the object is still. Now to describe the position, we required a set of axes and a reference point. We will take a rectangular coordinate system to learn this topic. Let us take three axes, namely x-axis, y-axis and z-axis. And when all the axes intersect at a point, it is called our origin point, which is also called as our frame of reference. As there are three axes, they all have a coordinate points which are x, y and z. Three coordinates x, y and z for x-axis, y for y-axis and z for z-axis. Now if we are in a straight line, then we can use only one axis. It is dependent on how much dimension we are using. If we use one dimension, then only one axis is required, and if we are using multiple dimension, then we will require all the three axes. If motion changes its position from one to another, then we can say that the object is in motion. Otherwise, if the motion is on a single point, then it is not changing, means the object is at rest, means it is a stationary object that cannot move from one position to another. We also take a clock in our coordinate system, and the coordinate system with the clock will constitute the frame of reference. So the thing required in our coordinate system will be three axes, x, y and z, and the intersection point of this axis, which is our origin, the three coordinates for our axis and a clock. So the requirement will be axis x, y and z, coordinates for our three axes x, y, z, the intersection point, which is known as origin, and lastly the clock. So our coordinate system will require these four things: axis, coordinates for the axis, intersection point and clock, and our system will be made using these four things. Now let us see an example of position. These are the different positions of an object, let's say car. So the origin point is this, that starts from 0. The right of our origin point are positive value and the left of our origin point are negative value. Means when our car moves in right side, that means our car is going in forward direction, so it will be move in positive. But when car moves in backward direction, the value of car will be negative as it is moving backward. For example, say let's take our car from O to Q. So the distance that is covered by car is in forward direction and the car will be at this point, place 240. But when car moves backward, the value of the point will be negative as it is moving backward. From this, we will see the path length. What the path length is? Simply path length means the length covered by a car from its starting point to ending point. For example, our car starts from position O. It moves from O to P. So, the path length covered by O to P is equals to 0 plus 360 means it is covered up till started from 0 and covered to 360. So, the value of our path length will be 360 as car covered this much of position. Similarly, if car goes from O to P and come back to Q, then what will be our path length? So, the value of our path length will be from O to P plus P to Q as car comes back to Q from P. So, the value of O to P, we all know that from O to P car covers 360 meters and from P to Q back means from 360 to 240. So, the difference covered in 360 to 240 is 120 meters. So, the distance of car from P to Q will be 120 meters. So, we can say that our car covered approximately 480 meters from O to P and from back P to Q. So, this will be our path length. In simple words, path length means total distance covered by our car. So, up till now, we have seen up to path length. So, let's summarize it. First of all, definition of motion. So, motion means change in an object, change in position of an object with respect to time. Now, how to describe the motion? So, two things are required. First is velocity and second is acceleration. So, velocity and acceleration is used to describe the motion. Third is position. Position of an object, the starting point, the ending point, the particular position where the object is in rest. Path length means the distance covered by the object. Now, we will see displacement. Basically, what is displacement? So, displacement means difference between the ending point and starting point of our object, say car. So, we require, let's take two positions x1 and x2 of our object with time interval t1 and t2. To define displacement, it is denoted by delta x. This symbol is called delta. In time interval delta t, which is given by difference between ending point and initial point. So, this will be our equation for the displacement. Delta x is equals to x2 minus x1, where x2 is our ending point and x1 is our initial point. If the value of x2 is greater than x1, then our answer of displacement will be positive. But if the value of x2 is less than x1, then the answer of our displacement will be negative. Let's take an example. We have seen this already. Our origin point is 0 and it is up to 400 meter in forward and in backward. Now, the main point about difference between displacement and path length is, in path length we only have magnitude and no direction, but in displacement we have both magnitude and direction. So, our car will move in forward also and in backward also. Now, the value of the magnitude and the displacement can either be same or different. For example, if our car moves from 0 to 360, then the value of magnitude will be 360 and the same of displacement will also be 360, as our ending point is 360 and initial point is 0. So, when we minus 0 from 360, the answer will be 360. So, the value of magnitude and displacement will be same. But when our car moves from O to P and then back to Q, the value of magnitude and the displacement will be changed. I will show you how. In magnitude, we will calculate total distance covered by time, means from O to P and then back to Q, means O to P plus P to Q will be 360 plus 120. So it will be 480. But in case of displacement, we have seen that the value of displacement will be calculated from ending point minus initial point. So when our car travels from O to P and then back to Q, the ending point of our car will be Q. So here the value will be O to Q, means 240 minus our initial point, which is 0. So it will be 240. So in this case, the value of magnitude will be 360, while the same of displacement will be 240. So this is the difference. So in simple words, the value of magnitude and displacement can either be 0 or same, or it cannot be same, as we have seen here. Now, the displacement can be also explained by using the time graph, which you already know. So we will take 3 scenarios and then see how much of graph will be formed. In first scenario, we will take a stationary object. Let's take an x-axis with respect to time interval t, and this is our origin point, which is 0. Let us assume that our car is at this position, which is 40, and as it is a stationary object, it will remain at 40 and does not go up. So it will remain at 40, but as we know that time will change itself, so up till, let's say, it's 10 seconds, but the car is stationary, so it will be on 40. At 20 seconds, the car will be at this point only, it does not go upward. At 40 seconds also, the car will be at this position only and does not change its position. So the graph for a stationary object will be a straight line. Now we will take a second scenario, which is uniform motion. Uniform motion means the car will change its position at equal distance with equal time interval. So let's see how the graph is formed. This is our x-axis and the time interval, the origin point. Now let's take different distances and different time intervals. As we have said that the car will be in uniform motion, means car will cover equal distance in equal time interval. So at the distance of 10, the time interval covered will be 10. So our line will form as like this. And as it will move forward, the distance will be covered equal as the time interval. So the line of uniform motion will be like this. So our uniform motion line will be formed like this. Okay, now we will cover third scenario, the mixture of first and second scenario. So let us assume that our car at initial point will be at stationary, means it will not cover a distance up to few seconds, let's say 10. So at initial point our car will not cover. At point 0 the car will be on rest, means it is not moving up till 10 seconds. Now after coming on 10 seconds, our car will start moving at equal distance at equal time interval. So it will form a uniform graph, a uniform motion. Now at point 30, it again stops and be stationary for up to 40 seconds. So this will be the graph formed for stationary plus uniform. At start up to 10 seconds our car is not moving. After 10 seconds car starts moving in a uniform speed, and after 30 seconds it stops and the graph is same as stationary. So these are the three scenarios of displacement. First was stationary, second was uniform, and third was combination of both stationary and uniform. So that's it for today.